In the vast, silent realm of the deep-sea Twilight Zone, the sun's golden light is long forgotten. Here, below the warmth and movement of the surface, bioluminescence takes over. This gentle, spectral glow is the only illumination these creatures will ever know. It is a soft, chemical light, created by the very inhabitants of the dark. Imagine a world where every flicker, every spark, is born from a living thing, a silent conversation in the eternal night. This unique light is wonderfully cold. It carries no warmth and generates no heat at all. It is pure, efficient chemical energy transformed into visual poetry. This cold, blue-green light drifts through the water, creating an ethereal ambience, a soft, natural rhythm that governs life in the dark. It assures these creatures that they are not alone, guided by the quiet luminescence of their neighbors. The Twilight Zone, also known as the mesopelagic layer, begins where most surface light disappears, around 200 meters. It plunges down to a depth of 1,000 meters. Throughout this immense space, sunlight becomes an ever-fading memory. It is a slow, graceful transition from day to night, lasting for hundreds of meters. In this fading light, only the resilient blue end of the solar spectrum can penetrate. To the human eye, everything would appear in shades of deep blue or absolute black. This blue dominance means that the creatures here must see the world in monochromatic tones, a simple, elegant palette of darkness and blue light. This uniformity is peaceful. There are no harsh, distracting colors, only the soft, deep blue of the infinite ocean. Bioluminescence serves three crucial, quiet purposes in this world. It is a means of subtle defense, a sudden flash to momentarily blind an attacker and allow for a graceful retreat. It is also used for the important task of attracting a mate, a unique, twinkling signal in the darkness. Most dramatically, it is a tool for hunting. A tiny, quiet lure, an irresistible beacon in the void. Luring a meal close enough to capture it, the light is a promise and a trap all at once. Defense, reproduction, and sustenance, the three pillars of deep-sea life, all silently orchestrated by this cold, gentle light. Many inhabitants of the mesopelagic zone have photophores, special organs that create light. These organs are most often placed on the underside of their bodies. This subtle arrangement is one of the deepest forms of camouflage found in nature, a technique called counterillumination. By adjusting the brightness of the light on their bellies, these creatures perfectly match the faint blue light filtering down from above. From below, a predator looking up sees only a continuous wash of faint blue, and the fish's outline vanishes completely. They become invisible shadows, silently moving through the water, perfectly blended into their environment. The light produced by deep-sea life is almost always blue or a calming blue-green. There is a simple, beautiful reason for this. Blue light travels the furthest through seawater. It is the most resilient color in the deep. This ensures that their signals can be seen over the vast distances of the ocean. Red light is absorbed almost instantly, fading into darkness just meters below the surface. Consequently, very few deep-sea creatures possess the ability to detect the color red. This creates a beautifully quiet visual environment, dominated by soft blues and blacks, a world free from the stimulation of bright, intense colors. Far deeper than the Twilight Zone, life thrives in the unlikeliest of places, the black smoker hydrothermal vents. Here, superheated water, often exceeding 350 degrees Celsius, pours from the seafloor, rich with minerals. In this extreme environment, magnificent tube worms take root. They have no mouth, no eyes, and no digestive tract. Their survival is a testament to the power of cooperation, or symbiosis. Inside their bodies live vast colonies of bacteria. These bacteria perform chemosynthesis, converting the noxious chemicals from the vents into all the food and energy the worms need. They live entirely independent of the sun, a beautiful, quiet ecosystem powered by Earth's internal chemistry. The anglerfish is a symbol of the abyss and a true master of silent hunting. The female carries a remarkable structure called the esca, a fleshy rod that dangles gracefully in front of her. This lure is tipped with a colony of glowing, bioluminescent bacteria. This light is not a sudden flash, but a constant, subtle beacon. It promises a small, warm haven in the cold, dark void. When small fish and crustaceans, drawn by the irresistible light, approach for a closer look, the massive jaws of the anglerfish open. It is a simple, effective, and profoundly patient strategy. Sometimes, bioluminescence is deployed as a desperate, final defense. A creature captured by a small predator may suddenly unleash an intense, frantic burst of light. This is not meant to blind the current attacker. It is a silent, glowing alarm. This brilliant flash attracts a much larger predator to the scene. The sudden light is an advertisement for a quick, easy meal. The hope is that the arriving, larger hunter will consume the initial attacker instead, giving the small, captured creature a momentary window to escape and drift away into the darkness. The creature known as the vampire squid from hell is far more gentle than its name suggests. When it senses danger, it executes a surprising, theatrical defense. It turns its webbed cloak almost inside out, covering its body. Most remarkably, it ejects a cloud of thick, glowing mucus. This sticky, brilliant cloud hangs in the water, flashing and shimmering, creating a luminous, distracting fog. While the predator investigates this mesmerizing display, the vampire squid drifts slowly and silently out of sight, disappearing into the cover of the deep. The deep ocean is not a place of absolute stillness. It is constantly traversed by vast, slow-moving currents. These currents perform the vital task of distribution, gently moving both nutrients and the larvae of deep-sea creatures throughout the immense habitat. These slow currents also carry the marine snow, a continuous, silent shower of organic particles drifting down from the surface. This sinking, gentle snow is the primary food source for almost every organism living on the deep seafloor. It is a silent, life-giving cascade linking the bright surface world to the dark abyss. Life in the deep abyss must withstand pressure that is unimaginable to us on the surface. At depths of 4,000 meters, the pressure is more than 400 times that of the air we breathe. To survive this crushing force, many deep-sea fish have evolved remarkably soft, gelatinous bodies. Their structure is mostly water, with minimal skeletal structure or rigid muscle. This lack of hard bone allows the pressure to pass through their bodies harmlessly. Their soft, flowing forms are a beautiful and elegant solution to the physics of the deep, allowing them to drift through the crushing weight without harm. The small but surprisingly fierce cookie-cutter shark earned its name from the neat, circular wounds it leaves on its prey. Its hunting strategy involves a clever use of light and shadow. The shark has photophores covering its entire belly, creating an almost perfect counter-illumination. However, a small patch near its mouth remains dark. This unlit patch is the key. From below, the shark's glowing belly disappears, but the dark patch looks exactly like a much smaller fish silhouetted against the faint light. When a larger predator comes close to eat the small fish, the cookie-cutter shark swiftly attacks, taking a neat, cookie-shaped bite. The deep-sea hatchetfish is perhaps the flattest fish in the ocean. Its body shape and structure are designed for extreme subtlety. It has large, upward-facing eyes that constantly scan the water above, searching for the telltale silhouette of a small meal drifting by. Its skin is almost metallic, acting like a mirror to its surroundings. This highly reflective surface helps it perfectly blend in with the faint, scattered light filtering down from the Twilight Zone above. Its mirrored skin is a key part of its perfect, almost invisible, camouflage. The magic of bioluminescence relies on the interaction of two specific, gentle chemicals. The first is luciferin, the compound that holds the potential to produce light. The second is luciferase, the enzyme that acts as a catalyst, speeding up the reaction. When these two elements are combined with oxygen, they silently and efficiently release a cold, pure light. This simple, elegant chemical reaction is the source of all the flickering, twinkling beauty we see in the dark, a perfect, self-contained biological light source. Not all deep-sea inhabitants create their own light directly. Instead, many creatures choose to harbor light-producing bacteria within their photophores. This is a quiet, powerful symbiotic relationship that benefits both partners immensely. The host creature offers the bacteria a safe, warm, nutrient-rich home. In return, the bacteria provide the host with a continuous, reliable source of light, essential for hunting, defense, or signaling. The famous flashlight fish is a prime example, its glowing pockets a living testament to cooperation. The dragonfish possesses one of the deepest ocean's most valuable secret weapons. Unlike most of its neighbors, it has the unique ability to produce and, crucially, to see red light. Since red light fades so quickly, almost no other deep-sea creature can detect it. The dragonfish uses a faint, almost invisible red beam as a silent, private searchlight. This red light illuminates its prey perfectly, but the illuminated fish remains completely oblivious to the beam. This gives the dragonfish a critical, silent predatory advantage in the perpetual darkness. The black swallower is an evolutionary marvel designed for gluttony in a sparse environment. It has an incredibly loose, hinged jaw and a highly elastic, distendable stomach. This allows it to consume prey much, much larger than its own body. This ability is a vital adaptation in the deep ocean, where a meal is rare and precious. When the opportunity arises, the swallower must be able to hold onto and digest its catch, no matter the size. Its life is a testament to patience and the readiness to consume a massive meal at a single, rare opportunity. Though the deep sea is not completely silent, light signals are much more common and reliable than sound in communication. Bioluminescence acts as a complex visual language, a quiet, flickering system of communication. Specific patterns, colors, and rhythms are used to convey crucial information. This silent, beautiful code helps organisms find their own species in the darkness. It is used for recognition, to establish boundaries, and to gently advertise reproductive readiness. Marine snow is more than just organic debris. It is the fundamental lifeline of the entire deep-sea food web. This slow, continuous shower includes the sinking remains of dead surface organisms, fecal pellets, and shed scales, all carrying valuable carbon and nutrients downward. As this snow gently descends, it sustains life at every level of the deep ocean. It is the only external energy source for the abyss. Every creature living in the vast, dark depths relies on this slow, peaceful descent of nourishment for its very existence. Some deep-sea sea cucumbers have evolved a truly brilliant form of distraction to escape their attackers. When threatened or disturbed, they have the ability to gently shed parts of their own bodies. These discarded pieces immediately begin to flash and wriggle intensely, becoming an irresistibly bright, moving decoy. The predator is drawn to the dramatic light show, attacking the glowing, separated piece. This precious distraction grants the sea cucumber the critical moments it needs to slowly and silently crawl away into the safety of the dark. The glass squid, or Tuthawenia zonopellucida, is a breathtaking example of deep-sea transparency. Living primarily in the mid-water column, where light levels are still slightly detectable, its body is almost entirely clear. This perfect transparency renders it nearly invisible to any creature looking at it from the side. Only a few internal organs, like its eyes and its digestive tract, must remain opaque. To hide these remaining visible parts, the squid often employs counterillumination. It gently lights up these internal structures, blurring their edges and making them fade into the ambient blue light. It is a creature of silence, shadow, and exquisite clarity. The deep ocean is home to a phenomenon known as deep-sea gigantism. Many species here grow to sizes far exceeding their shallow water cousins. One of the most famous examples is the giant isopod, an enormous relative of the common terrestrial pill bug. Scientists believe this great size is a direct consequence of the environment. The deep ocean is cold, which significantly slows down the metabolism of these creatures. Because they live slowly and conserve energy efficiently, they also experience very long lifespans, allowing them the time needed to reach their massive, quiet proportions. In the utter darkness of the deep, a creature must be able to find and recognize its own kind quickly. Bioluminescent displays act as highly species-specific signals. These patterns are often incredibly complex, involving specific rhythms, unique colors, or precise locations on the body. This visual code is their secret language. It ensures that a female can quickly signal her presence and readiness to mate, and that a male can confidently advertise his genetic suitability to only the correct partner. It is a flickering dance of recognition, a gentle conversation in the expansive, silent void. The ostracod is a tiny, delicate crustacean, yet it possesses one of the most brilliant defense mechanisms in the deep. When it senses a predator, it ejects a mixture of chemical compounds into the water. This mixture instantly reacts, creating a glowing, blue-green cloud that expands into a shimmering, luminous vortex. This dazzling light show is so effective that it blinds and confuses the predator just long enough for the tiny ostracod to slip away and vanish into the blackness. The siphonophore is one of the most beautiful and complex creatures of the deep. It is not a single animal, but rather a vast, flowing colony of smaller organisms called zooids. Each zooid is genetically identical, but specializes in a different function, like movement, feeding, or reproduction. They work together seamlessly to form one giant, unified creature, resembling a long, flowing chain or a crystal curtain. Some siphonophores have been observed to stretch over 40 meters in length, drifting like a quiet, bioluminescent rope through the endless current. The deepest parts of the ocean are found in its trenches and chasms, a region known as the Hadal Zone. This zone extends below 6,000 meters, descending into places like the Mariana Trench. The pressures here are astronomical, reaching over 1,000 atmospheres. Life here is sustained by extremophiles, creatures uniquely adapted to survive these crushing conditions. They are a powerful reminder that life can persist and thrive even in environments once thought to be utterly barren and impossible for existence. The ability to produce cold, living light did not arise just once in the course of evolution. The phenomenon of bioluminescence evolved independently countless times in different groups of deep-sea organisms. This is a remarkable example of convergent evolution. It means that, time and again, nature found that light was the most critical, most effective tool for survival in the permanent darkness. Its repeated appearance across different life forms is a testament to the absolute necessity of light in the silent, hidden world of the deep. The gulper eel is instantly recognizable by its impossibly large mouth. Its jaws are loosely hinged and disproportionate to its body, enabling it to open its mouth wider than almost any other creature in the sea. The entire front half of its body seems devoted to this expansive feeding mechanism. This design allows the gulper eel to consume fish that are much larger than its own mass. It simply waits, patiently, in the darkness, a quiet, gaping more ready for any passing opportunity. It is the very definition of an ambush predator, a study in silent readiness. A peculiar problem arises when a predator consumes a bioluminescent meal. The prey continues to glow inside the predator's stomach, effectively turning the predator into a luminous lantern visible to its own attackers. To counter this danger, many deep-sea predators have evolved a unique adaptation. They possess black stomach linings. This perfectly black interior absorbs any light emitted by their eaten prey. This internal shield ensures the predator remains completely camouflaged, their hunting success safely hidden from view. Many deep-sea squids have highly specialized photophores located strategically on their eyelids. These light organs are not for hunting, but for a delicate and specific form of social communication. These small, twinkling lights are used to recognize members of their own species and to communicate readiness to mate. They blink in complex, rhythmic patterns, like silent, secret eyes having a conversation. These subtle flashes create a beautifully complex, visual dialect in the silent deep. The word abyss itself means bottomless in ancient Greek, reflecting the mystery of the deep. The abyssal plain is a vast, flat, and remarkably expansive region of the ocean floor, typically lying between 3,000 and 6,000 meters deep. Life here is scattered and extremely sparse due to the lack of food and light. Creatures on the abyssal plain move with a great slowness, conserving their precious energy. It is a realm of profound quiet and immense geological stillness, a slow-motion landscape of mud and water. The ecosystems around deep-sea vents, while vibrant, are also intensely dynamic. They are constantly subject to change, often destroyed and rebuilt by the same volcanic and seismic activity that created them. The life forms that thrive here must be remarkably resilient. When an event becomes inactive or erupts, the organisms must relocate, sometimes drifting across vast, barren expanses to find a new vent plume. Their ability to adapt to extreme and changing conditions is a testament to the powerful persistence of life itself. Some inhabitants of the Twilight Zone have developed unique tubular eyes. Unlike normal eyes, these are fixed and point directly upward, giving the fish excellent binocular vision. This specialization maximizes their ability to spot a silhouette against the faint light filtering down from the surface. These eyes are constantly scanning the tiny, precious patch of light directly overhead. This provides a sharp, focused view of the limited space where their prey might appear. It is a highly specialized tool for efficient hunting in a low-light environment. The life cycle of the anglerfish is marked by extreme sexual dimorphism. The female is large, fierce, and carries the glowing lure. The male, by contrast, is tiny and lacks the hunting ability of his mate. He is dedicated only to reproduction. Upon finding a female through scent, the male permanently fuses himself to her body, becoming a parasitic attachment. He slowly degenerates, becoming merely a vessel for sperm. This ensures that the female always has a mate ready, a profound, quiet commitment to survival in the dark. Beyond defense and attraction, bioluminescence is also used specifically to confuse and startle. A sudden, intense flash of light in the total darkness can momentarily overwhelm the visual system of a predator. This burst of light acts like a sudden, silent explosion, granting the prey a critical second or two to change course and swim away quickly. It is a highly effective tactic in an environment where even a temporary loss of focus can mean the difference between life and death. The coelacanth is a majestic, lobe-finned fish that lives deep in the ocean. For centuries, scientists believed it had gone extinct with the dinosaurs. The discovery of a living coelacanth in 1938 was one of the most significant finds in marine history. It is now regarded as a living fossil, a rare glimpse into the evolutionary past of marine life. Its ancient form and slow movements speak of a quiet, undisturbed history that spans millions of years in the stable, deep environment. Certain species of deep-sea brittle stars utilize a spectacular, wave-like light display. When they are disturbed or gently touched by a predator, their entire arm sections light up rapidly. The light travels in a mesmerizing, shimmering wave down the length of their arms. This bright, rapid light show is a powerful and beautiful warning. It often serves to startle the attacker or signal to a larger predator that an interesting event is taking place. The chimera, also known as the ghost shark, is a graceful deep-sea relative of the true sharks and rays. It is characterized by its long, distinctive, pointy nose. It uses this specialized snout to sense its environment in the utter darkness. The ghost shark relies on electroreception to hunt, sensing the weak electrical fields generated by the muscle movements of its prey. Like many deep-sea residents, it uses a non-visual sense to navigate and hunt, relying on the quiet, pulsing energy of life around it. The mysteries of the deep are slowly being unveiled thanks to advanced technology. Scientists use remotely operated vehicles, or ROVs. These are robotic submarines controlled from a ship above, equipped with powerful lights and high-definition cameras. The ROVs dive into the dark abyss, bringing back stunning images and critical samples of this hidden world. They are our eyes and hands in the deep, allowing us to quietly observe the beautiful, strange creatures without disturbing their ancient, silent existence. The control over light production is often remarkably precise. The creature actively controls its light through muscle contraction, turning the photophore on or off instantly. This allows them to create sharp, deliberate flashes, not just a simple glow. They can also modulate the intensity of the light, subtly dimming or brightening the glow to match the faint ambient light. This fine-tuned control is essential for complex signaling, allowing for nuanced, gentle communication in the absolute dark. Some creatures have a unique defense mechanism. They don't just flash, they release glowing substances externally. When threatened, they squirt a bioluminescent compound into the water around them. This creates a brilliant, shimmering cloud that hangs in the water, distracting and dazzling any pursuing predator. It is a slow-motion fireworks display, a liquid, luminous decoy that gives the creature precious moments to make its quiet escape into the deeper darkness. The deep ocean is characterized by its profound and unwavering cold. Temperatures typically hover just above freezing, remaining consistently low throughout the vast abyssal plains and trenches. This constant cold has a significant impact on the physiology of its inhabitants. The low temperatures dramatically slow down the metabolism of deep-sea creatures. They consume less energy, move more slowly, and therefore do not need to eat as frequently. This is a crucial adaptation in an environment where food is incredibly scarce, allowing for long, quiet periods of energy conservation. The tripod fish is one of the most serene and patient hunters of the deep seafloor. It has evolved incredibly long, stiff rays on its pectoral and pelvic fins, which it uses like stilts. It perches delicately on these extended fins, elevating itself above the soft sediment. From its elevated position, the tripod fish faces into the gentle current, its mouth slightly agape. It waits with immense patience, silently sensing for any small, drifting food particles to be carried its way. It is an almost static, perfectly still hunter in a slow-motion world. Not all bioluminescence is confined to the deep. Some species of bioluminescent plankton live in the surface waters and are responsible for the breathtaking phenomenon known as sea sparkle. This occurs at night, transforming the ocean's surface into a glowing canvas. When these tiny organisms are disturbed, perhaps by a boat's wake or a breaking wave, they flash brightly with a brilliant blue light. This creates ethereal, glowing patterns in the water, making the ocean seem to shimmer with 1,000 tiny stars. It is a gentle, natural light show on the surface. The Dumbo octopus, named for its prominent ear-like fins, is one of the most charming inhabitants of the deep. These large, graceful fins help it to slowly hover and gently propel itself through the vast water column. It is one of the deepest-dwelling octopus species known. Its movements are wonderfully fluid and serene, a slow dance in the darkness. The Dumbo octopus drifts quietly through the deep-sea currents, a peaceful, almost weightless presence. Its gentle existence is a quiet ballet in the cold, dark world. In the vast, dark expanse of the deep ocean, establishing and maintaining territory can be a challenge. Bioluminescence provides a unique solution. Certain fish will flash a specific, often intense pattern of light to mark their territory. This display acts as a silent, yet clear, warning to intruders. It is a visual boundary marker, a glowing, keep out sign in a world without fences. This flashing signal allows them to defend their space without the need for physical confrontation, maintaining a quiet order in the deep. The loose-jaw fish possesses a remarkable predatory advantage. It has specialized photophores located beneath its eyes that emit red light. As we know, most deep-sea creatures cannot see red light at all. This means the loose jaw can scan its surroundings with a silent, invisible searchlight. It illuminates its unsuspecting prey in a color they cannot perceive, gaining a crucial edge. It is a master of selective illumination, a ghost hunter in the red spectrum. The deep-sea environment is characterized by its remarkable stability. There is little to no variation in temperature, salinity, or light levels over vast periods of time. This constancy has profound implications for the evolution of its inhabitants. In this unchanging world, creatures evolve slowly and become highly specialized for their specific niches. Their forms and functions are perfectly tuned to their stable surroundings, creating a world of ancient, unchanging adaptations. Far from the sunlit reefs, vibrant deep-sea coral gardens flourish in perpetual darkness. These magnificent structures are found on seamounts, ridges, and canyons, often at great depths. Unlike their shallow water cousins, they do not rely on photosynthesis. Instead, these corals are filter feeders, gently sifting organic material and marine snow from the slow-moving currents. These ancient, slow-growing gardens provide crucial shelter and habitat for a multitude of other deep-sea species, creating quiet oases of life in the dark. One of the most counterintuitive uses of bioluminescence is the burglar alarm effect. When a small prey item is caught by a predator, it will flash intensely and repeatedly. This might seem self-defeating, but it has a specific purpose. The bright, frantic flashing attracts a larger predator to the scene. This larger hunter is drawn to the disturbance, and often, it will attack the original, smaller predator instead. This chaotic diversion can allow the original prey to escape in the confusion, a dangerous but clever gambit. Some creatures use their bioluminescence not just to disappear, but to actively mimic the faint sunlight filtering down from above. This is another sophisticated form of counterillumination, allowing them to perfectly blend into their surroundings. They precisely adjust the intensity of their ventral photophores, matching the scattered light. By doing so, they eliminate their own silhouette, making their bodies completely vanish from the sight of predators looking up. It is a masterclass in subtle, living invisibility. Despite centuries of ocean exploration, the deep ocean remains largely a mystery. Vast areas of this immense habitat are still completely unexplored by humans. It is often said that we know more about the surface of Mars than we do about the deepest parts of our own planet's ocean. The creatures we have discovered so far represent only a small fraction of the life that likely exists there. There are countless species, with their own unique adaptations and bioluminescent secrets still waiting to be quietly uncovered. The deep-sea smelts are small, delicate fish that often form quiet schools. They possess numerous tiny, evenly distributed photophores along their bodies. These subtle light organs play a crucial role in their social structure. The faint, coordinated flashes emitted by these photophores help the school stay together in the perpetual darkness. These gentle, synchronized blinks act as a silent, visual communication, allowing them to move as one cohesive unit through the vast, dark water. The extreme pressure of the deep ocean poses a unique challenge to the biological processes of its inhabitants. Normal enzymes, which drive all cellular reactions, would simply cease to function under such immense force. Deep-sea organisms have evolved highly specialized pressure-adapted enzymes. These enzymes are structurally different, allowing them to maintain their function and efficiency even at crushing depths. This biological ingenuity is key to their quiet survival in an otherwise impossible environment. While often used for defense or attraction, bioluminescence can also be deployed aggressively. Certain deep-sea squids, for example, will use intense, rapid flashes of light to ward off rivals or to assert dominance. The sudden, dazzling light can be perceived as a direct threat, a visual declaration of strength in the darkness. It is a silent, yet powerful, display of aggression, helping to establish order and territory without physical combat. At deep-sea hydrothermal vents, life flourishes without any energy from the sun. This is due to the incredible process of chemosynthesis. Unlike photosynthesis, which uses light, chemosynthesis uses chemical energy, primarily from sulfur compounds. This chemical conversion is the bedrock of entire, vibrant ecosystems that exist in complete darkness. It is a powerful reminder that life finds a way, harnessing energy from Earth's own internal forces to create thriving, quiet oases in the abyss. The colossal squid, Mesonicoteuthis hamiltoni, is a creature of legend and immense scale. It is the largest known invertebrate on Earth, weighing hundreds of kilograms and inhabiting the freezing, abyssal waters of the Southern Ocean. Its most remarkable feature might be its eyes, which are the largest in the entire animal kingdom. These massive, quiet orbs are perfectly adapted to gather every last photon of light in the deepest, darkest trenches, allowing this giant to hunt in near total blackness. To further refine their communication, some deep-sea creatures possess specialized light filters within their photophores. These filters can change the color of the emitted light, adding another layer of complexity to their signals. This ability allows for even more intricate and private communication. A specific color, visible only to their own species, might convey a secret message, ensuring that only intended recipients receive the information in the vast, silent conversations of the deep. Even in its remote and silent depths, the marine environment is facing increasing threats. Emerging practices like deep-sea mining, which targets valuable minerals on the seafloor, pose a significant danger. Deep-sea trawling, though less common now, also disturbs these fragile habitats. These activities are particularly damaging because deep-sea ecosystems are slow to grow and recover. The delicate balance of these ancient worlds is easily disrupted, highlighting the urgent need for careful, quiet conservation. The deep ocean plays a profoundly important and quiet role in regulating our planet's climate. It acts as a massive carbon sink, absorbing and storing an immense amount of carbon dioxide from the atmosphere over vast timescales. This long-term sequestration of carbon is vital for maintaining a stable global climate. The health and undisturbed function of the deep ocean directly influence the air we breathe and the stability of our entire planet, a silent, powerful global regulator. In the zones of absolute darkness, eyes become less important. Many deep-sea fish have vestigial eyes, meaning they are poorly developed, shrunken, or even entirely non-functional. They have quietly lost the need for vision. Instead, they rely on other, more effective senses. Their lateral lines detect subtle changes in water pressure and movement, guiding them through currents. Highly sensitive chemoreceptors detect dissolved chemicals, helping them find food and mates. These other senses are their quiet guides in the boundless dark. The comb jelly, or ctenophore, is often mistaken for a true jellyfish, but it belongs to its own separate phylum. It propels itself through the water using 8 rows of tiny, hair-like structures called cilia, which beat in a coordinated rhythmic wave. As the cilia move, they scatter and refract light, creating a dazzling, shimmering rainbow effect. This beautiful display is not actually bioluminescence, but iridescence, a purely physical light effect. It is a quiet, natural light show, transforming the comb jelly into a slow-moving prism in the darkness. The chemical reaction that produces bioluminescence is being studied intensely for its potential uses in human medicine and research. The reaction is remarkably efficient, producing light with very little wasted energy. Scientists are utilizing the luciferin and luciferase system as sensitive biological tracers. This allows them to track complex processes inside the human body, such as gene expression or disease progression. The quiet, cold light of the deep is offering new tools to understand the complexity of life. The female deep-sea anglerfish is often a profound picture of solitude. She drifts through the vast, open water column, alone in the immense darkness. Her entire existence is centered on the light of her lure. She relies completely on this quiet, subtle beacon to bring sustenance to her isolated spot in the ocean. This solitary existence demands immense patience, a slow, gentle drift punctuated only by the sudden, rare opportunity to feed. The phenomenon of bioluminescence was observed by early mariners for centuries, long before its scientific explanation was understood. Sailors often reported patches of the sea glowing intensely at night, describing phenomena like milk seas or burning seas. These vast, shimmering glows were due to huge blooms of bioluminescent microorganisms. While the biological origins were only scientifically confirmed much later, these quiet, historical sightings attest to the deep, natural beauty of light in the ocean. In a few specialized deep-sea fish, bioluminescence is used for a quiet, internal purpose. They possess light organs that specifically illuminate their mouths or throats. This light serves a functional, momentary purpose when feeding. This internal glow helps them briefly see the small prey they are about to consume. It also helps to attract small, unidentifiable food particles directly into their jaws. It is a discreet, momentary flashlight used only for the moment of consumption. The deep ocean encompasses over 60% of the Earth's surface, and considering its incredible depth, it represents the largest and most voluminous single habitat on our planet. Its sheer scale is immense and almost incomprehensible. This vast, dark domain is the silent foundation of global ecology. Its immense size and volume underscore just how much of life on Earth remains hidden, operating in the perpetual darkness and quiet of the deep. The barrel-eye fish possesses one of the most remarkable heads in the natural world. It is completely transparent. Its delicate, fluid-filled dome allows its large, barrel-shaped eyes to rotate and look upwards through its own head. This unique adaptation gives the barrel-eye an incredibly wide field of view, specifically designed to spot the faint silhouettes of small crustaceans or jellies drifting directly overhead. It is a quiet, biological telescope, perfectly tuned to the detection of prey. Certain deep-sea worms have a fascinating defense mechanism involving a glowing, sticky trail. When threatened, they release a bioluminescent substance that forms a long, intensely bright trail that adheres to the water. This trail remains luminous for a significant time, acting as a perfect, long-lasting decoy. The worm, meanwhile, quietly crawls away to safety, leaving the predator to investigate the brilliant, shimmering distraction. The process of courtship in the deep sea is one of immense difficulty and quiet reliance on light. Finding a suitable mate in the absolute darkness of the vast ocean is a challenge that requires precision and planning. Bioluminescent signals are the solution, ensuring both species recognition and the communication of reproductive readiness. Without these specific, carefully timed flashes, the chance encounters necessary for reproduction would be almost impossible in the boundless void. Marine snow acts as a crucial, gentle connector, physically linking the sunlit surface layers of the ocean to the cold, dark abyss. It is the physical manifestation of the flow of energy from the light zone to the dark zone. This slow, continuous, gentle rain of organic material ensures that the energy captured at the surface by photosynthesis is eventually delivered, particle by particle, to sustain all life in the deep. It is a quiet, continuous lifeline. Some deep-sea fish that produce light have evolved specialized red patches or pigments near their photophores. These pigments are designed to absorb the blue light that the fish itself produces. This serves a protective function, preventing the fish's own light from illuminating its body and making it visible to predators. It keeps the light intensely focused on the intended target, the lure or the signal, while ensuring the rest of the body remains in perfect, quiet shadow. In stark contrast to the barren abyssal plains that surround them, the communities clustered around hydrothermal vents are incredibly dense. Life is packed tightly into the small zones where the chemical plumes emerge. These areas, powered by chemosynthesis, sustain a remarkably high biomass. This intense concentration of life is a powerful, quiet, localized ecosystem, demonstrating life's ability to explode in abundance wherever a stable energy source is found. The viperfish is an iconic deep-sea predator, known for its long, slender body and terrifying fangs. Its teeth are so long they curve back and upward, forcing the fish to open its mouth wide to accommodate them. These fangs are not for chewing but for piercing and holding prey with absolute certainty. The viperfish also utilizes a delicate string of photophores along its body, assisting its silent, relentless hunting in the dark water. Life in the deep ocean operates at a dramatically slower pace. Many deep-sea species are slow growers, taking many years, sometimes decades, to reach full maturity. This is a direct consequence of the cold temperature and the scarcity of available food. Because they grow so slowly and conserve energy so efficiently, many deep-sea creatures also enjoy incredibly long lifespans. Their existence is characterized by a slow, quiet patience and a profound longevity. The deep-sea environment, due to its remarkable stability and lack of change over geological time, acts as a pristine archive of evolution. It is a place where ancient life forms can persist for millions of years. The consistent conditions mean that these habitats preserve unique genetic diversity. It is a quiet, deep library, holding living records of evolutionary history that have vanished from the more volatile surface world. Bioluminescence is sometimes used with great precision in a searchlight pattern. Rather than a continuous glow, some fish can focus and direct a specific, brief beam of light. They use this like a quiet flashlight to scan the immediate area. This directed beam helps them momentarily illuminate and find camouflaged prey. Because they use their light sparingly and strategically, they conserve energy and minimize the risk of revealing their own position to larger, waiting predators. In some of the deepest trenches and sheltered basins, the lack of water circulation leads to the formation of anoxic zones. These are areas entirely depleted of oxygen, rendering them uninhabitable for most complex life. Only highly specialized, anaerobic bacteria can survive here, relying on chemical processes that do not require oxygen. These quiet, Deep areas are sometimes called dead zones, but they still host a unique, non-oxygen-breathing form of microbial life. Many beautiful, gelatinous creatures in the deep ocean are often incorrectly lumped together as jellyfish. However, there is a technical distinction. True jellyfish belong to the phylum Cnidaria. The siphonophores and ctenophores are separate, equally important groups. Their soft, flowing, gelatinous bodies are a common, quiet adaptation to the extreme pressure, making them almost weightless in the dark water. The commercial activity of deep-sea fishing poses threats even to the creatures living far below the nets. Trawlers often catch species that undergo vertical migration, creatures that swim up to the surface at night to feed. By removing these migrating organisms, the fishing disrupts the natural flow of nutrients down into the deep ocean. This interrupts the quiet rhythm of the marine snow cycle, impacting the entire ecosystem below. The biological structures responsible for creating light, the photophores, are often far more complex than a simple sack of glowing cells. They are marvels of biological engineering. Many photophores contain intricate components, including lenses to focus the light, reflectors to intensify it, and color filters to fine-tune the hue. This complexity allows for the precise, controlled creation and manipulation of light signals in the deep. The yeti crab, Kiwa hirsuta, is a fascinating creature found near hydrothermal vents. It is instantly recognizable by its long, hairy claws. These structures are not merely decorative, they serve a crucial, life-sustaining purpose. The crab actively cultivates dense mats of bacteria on these hairs. It then grazes on this bacterial lawn for food. This unique, quiet form of chemosynthetic farming allows the yeti crab to thrive near the vent openings. In many deep-sea organisms, bioluminescence is directly activated by a physical stimulus, most commonly touch. This is a defense mechanism designed for immediate, reflexive action. When the creature is gently touched or grasped by a potential predator, it instantly unleashes a brilliant flash. This sudden, tactile activation acts as a powerful, physical warning or startle mechanism, giving the prey a chance to escape the moment of contact. The deep-sea snailfish holds the quiet, impressive record for living at the greatest depths ever recorded for a fish. It has been found thriving in the extreme pressures of the deepest trenches, below 8,000 meters. Its soft, gelatinous body is perfectly adapted to the crushing environment. The snailfish is a powerful symbol of the resilience of life, quietly existing and thriving where few other vertebrates can survive. The systematic exploration and discovery of the deep sea is a relatively recent human endeavor. Before the late 1800s, the common belief was that the abyss was too dark, cold, and pressured to sustain any life. The first successful deep-sea trawls revealed a world teeming with strange, quiet life. Our understanding of this vast, hidden world is constantly expanding, offering endless opportunities for quiet wonder and discovery. Certain species of bioluminescent plankton use their light in a spectacular display of reproduction. They gather together in enormous numbers, forming quiet, massive mating swarms. When synchronized, these swarms create dazzling, flashing light displays visible over huge distances. This intense, collective visual advertisement helps to attract mates from miles away, ensuring the continuation of their species. The black coloring of many deep-sea creatures is an elegant and powerful defense strategy. They possess skin and scales that are so dark, they absorb virtually all ambient light, including any faint bioluminescence. This deep, velvety blackness makes them nearly invisible in the dark water. They are the ultimate shadow dwellers, perfectly designed to blend into the absolute quiet of the abyss. The chemical reaction that produces bioluminescence is a marvel of efficiency. Almost all of the chemical energy used in the reaction is converted directly into light, with very little being wasted as heat. This incredibly high efficiency is why the light is referred to as cold light. It is a testament to the powerful, quiet precision of biological engineering, maximizing light output while conserving energy. The deep ocean is home to the largest migration on Earth, a massive, quiet movement known as vertical migration. Hundreds of millions of creatures ascend from the depths to the surface layers to feed at night, under the cover of darkness. Before the first light of dawn, they gently sink back down to the safety of the dark abyss. This daily, synchronized movement is a fundamental rhythm of the ocean, a quiet, immense ebb and flow of life between the light and the dark. The famous glowing lure, or esca, of the female anglerfish is home to an extremely high concentration of light-producing bacteria. This density ensures that the light produced is continuous, bright, and utterly mesmerizing to prey. The anglerfish carefully provides the bacteria with a constant supply of nutrients, maintaining this vital symbiotic partnership. The continuous, quiet glow of the lure is the key to the hunter's existence in the dark. The vast, flat expanse of the ocean floor, particularly the abyssal plain, is covered in fine sediment. This sediment is composed of the constant, slow accumulation of marine snow, dust, and tiny mineral particles settling over immense spans of time. This quiet, slow accumulation creates a gentle, deep geological record. It is an archive of Earth's history, quietly preserving data about past climates and surface conditions in its layers of fine, undisturbed mud. While the vast majority of deep-sea bioluminescence is the calming blue or blue-green, there are notable exceptions that add complexity to the communication. Some ostracods, for example, are known to emit a distinctive yellowish-green light. This diversity in color is subtle but highly significant. It allows for the existence of multiple, independent signaling channels, ensuring that different species can send and receive their quiet messages without interference. The fong-tooth fish, despite its terrifying name, is actually a relatively small fish. It is, however, defined by its disproportionately large and deeply impressive teeth. These fangs are so enormous that when the fish closes its mouth, the teeth must slide into specialized sockets in the roof of its skull. This adaptation ensures that once prey is caught, it cannot escape, guaranteeing a successful capture in the dark, food-scarce world. The entire deep-sea environment is filled with creatures that are incredibly specialized. Every life form, from the massive squid to the tiniest glowing bacteria, is perfectly adapted to its narrow, dark niche. Their survival strategies are a complex tapestry of biological innovation, a quiet testament to the endless possibilities of life. They demonstrate the resilience and ingenuity of nature operating under the most extreme conditions. Despite all the discoveries made, we still have much to learn about the meaning of the light. The precise sequence and function of many flash patterns and bioluminescent displays remain unknown to us. The complex, flickering language of the deep is still largely untranslated. It is a constant, quiet mystery, a secret conversation continuing below, waiting patiently for us to eventually understand its subtle grammar and meaning. In certain species of deep-sea fish, the patterns and intensity of their bioluminescence change as they age. These shifts often correlate with important biological milestones. The change in light display can signal the onset of sexual maturity, communicating to other members of the species that they are now ready to mate. This ensures that the proper partners are attracted at the exact right moment, a subtle biological evolution. The formation of hydrothermal vents creates powerful deep-sea oases. These are localized areas of intense biological activity that stand out starkly against the surrounding barren landscape. These ecosystems are entirely independent of the sun's energy, relying instead on the Earth's internal chemistry. They are a profound example of life's ultimate adaptability, proving that biological energy can be harvested from the rock itself. The deep sea remains the last true dark frontier on Earth. It is a place of absolute quiet, immense space, and unending wonder. It operates on a geological timescale, far slower and more patient than the fleeting existence of surface life. This vast, cold domain is a testament to the power of adaptation, where life has quietly and persistently conquered the challenges of darkness and pressure with elegant, glowing solutions. The gentle, continuous glow of deep-sea bioluminescence offers a quiet comfort. It is a profound, beautiful reminder that even in the most profound darkness, light can always persist. This light is not aggressive or harsh. It is soft, subtle, and natural. It is a quiet symbol of life's persistence, a peaceful assurance that even in the cold and the silence, energy and beauty continue to flow. The secret life of the abyss continues its slow, quiet existence right now, below the waves. The delicate dances of light and shadow, the long hunts, and the slow, geological rhythms are all ongoing. This silent, majestic world waits patiently for us to quietly observe and understand its complex systems. Rest now, and drift with the final, quiet currents of the abyss, accompanied by the gentle glow of its hidden lights.